We're given the first two terms of a geometric sequence, and they're 5 and 10. It's important to note that it is geometric this time, it's not arithmetic. So that means we're multiplying. So if 5 is our first term and 10 is our second, that means we'd be multiplying by 2. So if we take 10 times 2, we have 20, and 20 times 2, we have 40. Now we need a recursive formula. This is like the now next. So we would say a sub n equals my a sub n minus 1 times 2, because we're multiplying by 2 each time since it's geometric. We always need to give our starting value, and they gave it to us as a sub 0 is 5. Now the function formula, for our function formula, we want it to be able to plug in our sub value and get the correct answer, so we'll write it in a of n form. We are multiplying by 2 each time, but we always give our beginning number when we're doing a geometric. So we're starting with 5 times our rate of multiplication each time, so 2 to the n. You've seen this form before. Always check if your equation actually works. So if you would plug in 0 into your equation, 2 to the 0 makes 1, 1 times 5 makes 5, and that works. Try it with 1, 2 to the 1 is 2, and so 2 times 5 makes 10. That should work. Now we want the sum of the first 15 terms of the sequence. Remember, this equation for the sum of a geometric sequence is and then you have your beginning term times 1 minus the rate to the n all over 1 minus the rate. For this problem, that looks like we want the sum of the first 15 terms. So we would have our beginning term, which is a sub 0, so 5, times 1 minus our rate of multiplying is 2 to the 15, because n is how many terms we want, all over 1 minus 2. We plug that into a calculator, and that gives us 163,835. That'd be the sum of those first 15 terms for that geometric sequence.